So we've looked at two approximate methods plus the rectangles, but for our purposes this year, the trapezoidal rule and the Simpson's rule for finding the area under a curve. But they're only approximate methods. And so what we're going to do now is actually finding the primitive, which we've talked about, the capital F, and it's minusing the two different rectangles from that other graph that we did. So if you have the sum of the areas here of x to the n dx, the primitive of that, which we then have to sub the numbers in once we have them, is x to the n plus 1 over n plus 1 plus c, which we'll talk about in a minute. So it's the opposite of differentiation. You're adding 1 to the index and you're dividing by that number. Whereas in differentiation, if you remember, let's say we had something like 2x to the 4th, we would multiply. 4 by 2 is 8. So we're multiplying instead of dividing. And then it was x, and we would reduce the index by 1. So it's total opposite operations. Now we're adding 1 to the index and we're dividing by it. So let's rub that out. Can I rub that out? Okay, the reason we put a c here, c is just a constant number without x, so it's a number. And the reason we put it there, and later on we actually need to evaluate it, is if you have a function like this and you're trying to differentiate it, which is the opposite operation of finding a primitive, then you can do the x part, no dramas. If there was a number there and we derived it, the derivative is 0 down here. But of course, once we're given the derivative and we have to integrate it, we don't see a 0. So there could have been a number there, so we put a plus c. And then there's extra information later on and we actually go and calculate what c is. So let's see how it works. So we're going to find the primitives of these functions. And I might actually number them. 1, 2. Okay. So, number 1. We have 6x cubed, 5x squared and 4. So the rule is add 1 to the index and then divide by that number that you've created. So, primitive is 6x, add 1 to the number is 4, and divide by that number. We'll simplify it in a minute. Plus 5x, add 1 to the number, divide by it, minus. Now think back to differentiation. If we have a minus 4 here, okay, so this is like the derivative, we're now going the opposite direction. Then what do I need to put here such that if I derived this term here, I get a minus 4 as an answer? And the answer is I need to put an x there. So that if I went the opposite way, 1 times minus 4 is minus 4x to 0. So remember when we had something like that, just with an x and the coefficient becomes the derivative. Okay, and every time we need at the end to write a plus c for these indefinite ones. Okay, and we need to simplify it. So it's 3 on 2x to the 4th plus 5 on 3x cubed minus 4x plus c. Number 2. So in this one, we've got negative indices. That's okay, works exactly the same. So 3x, we add 1 to it now, go the right way, and divide by it, plus x to the minus 2 on minus 2, plus 2x to the minus 1 on minus 1, plus c. Turn that up there a little bit. Perfect. So let's just simplify that. So do the numbers first. 3 divided by minus 3 is minus 1. So we know there's a fraction as well because you've got a negative indice. So the x cubed goes down the bottom and we've got a minus 1. Next one, that's a plus, that's a minus. So mix means minus. On the top is a 1 and on the bottom is 2x squared. And again, minus, and that was 2 on the top over x plus c. Yes, we could get a common denominator, but there's no need at this stage. Okay, number 3. Now, we've looked at this before in Simpson's rule. If there's a dx on the top as opposed to the end, we're going to rewrite that. And we'll put just the 1 there, 1 over x to the 8th dx. It's the same thing. Now at this stage we don't have any rules for finding a primitive of fractions, so we need to try and rewrite that. So that's the same as saying x to the minus 8 dx. If I add 1 to it, that's x to the minus 7 on minus 7 plus c. And number 3. And so that is minus 1, 1 on 7x to the 7 plus c. Okay, number 4. Is x to the cube dx. So just because there's a fraction there, rule is exactly the same. So add 1 to the index. So 1 plus 1/3 is 1 1/3. But don't use mixed numerals. Mixed fractions use improper fractions. So it's x to the 4 on 3 divided by 4 on 3 plus c. Well, we can't have a fraction on a fraction. So what happens is invert and multiply. We flip this. So instead of 4/3 it becomes 3/4 x to the 4 on 3 plus c. And if we get our square roots happening, that's 3/4 of the cube root of x to the 4th plus c. Okay, the next one is a fraction, but so far we've got no rules for fractions, so we need to simplify it somehow. Oops. So let's break it down. X to the 6th on x cubed is the integral, or the primitive of x cubed, minus. And then we've got x to the 5th divided by x cubed. Our index laws tell us to subtract those indices. So that's minus 3x squared plus, then we've got x to the 4th over x cubed. That cancels out to an x. So don't forget we simplified, but then we still have to find the primitive. So it's x to the 4th on 4 minus 3x cubed on 3. If there's a coefficient at the front, it just stays there. You don't actually do anything with it. Plus 2x squared on 2 plus our c. So it's 1/4 x to the 4th minus x cubed plus x squared plus c. I'm going to leave number 6 for a moment because that does require a special rule. Number 7, if we section that off, and we start with number 7. So there are no rules for products or for brackets to find primitives, so we just need to expand it out. So number 7, if we expand that trinomial out, it's x squared plus 3x minus 10 dx. So we've expanded it, now we need to find the primitive. So it's x cubed on 3 plus 3x squared on 2 minus 10x plus c. So that's a third x squared, 3 on 2, so that's a cubed, x cubed, minus 10x plus c. And the last one, number 8, is 3 on x squared. Well, we can't find the primitive there, so we need to say that's the same as 3x to the minus 2, and then find the primitive of that. So it's 3x to the minus 1 on minus 1 plus c, which equals, so that's a minus, it's a 3 on x plus c.